Welcome to my YouTube channel. In this video, we're gonna learn about how to find improper integrals. Before that, we are gonna see what are the types of integrals. So let's begin. See, there are the four types of integrals as definite integrals, then indefinite integrals, then proper integrals, then improper integrals. So from these four types of integrals, the first type of integral is definite, which states that here there are limits for the function on which we want to find the integration. Okay, so such type of integration are recognized under definite part. Okay, and in indefinite part there will be no limits of integration. It will be just simply integration of f of x dx. So in the intermediate level, you all know about this thing. What is this definite and indefinite integral? Now we will see this proper and improper integral. So first we will see what is a proper integral. Okay, so this is an integral where it may be of two types. Okay, one type is if the limits of integration are finite. Okay, so what does that finite term means? Finite means any finite value. Okay, that means it should not be of the type infinite or minus infinite, right? So finite means any real number. Okay, next, the second condition is that the function whatever we want to do integration, it should be continuous in that domain. Okay, suppose if I am writing a to b f of x dx, that means that I have to find the integration of f of x in the domain. What is the domain? So domain is domain of integration, that is here the x belongs to a to b. So see, this is a closed interval, that means the value of x exists for a and b too. That means this f of x value should define on the interval ab. So the second condition comes from here that f of x should be continuous. Okay, on which interval? Now on the interval on which the limits of integration is given, that is a to b. So see, it is the closed bracket, that means this f of x should be defined at the point a also. Okay, it should be defined at a, and it should be also defined at the point b and all the points between a to b also. Okay, so this is the definition of proper integral. Now we will come to improper integral. So what is the improper integral? Simply the integration which is not proper. That means from the two conditions of the proper integral, either one of the condition may fail. Okay, suppose if the limits of integration are not finite. Okay, here the condition is that this should be finite. Okay, but if this condition fails, then we will tell this as a improper integral. Or what can happen? Or see, in the second condition it is written that f of x should be continuous on this closed interval ab. So in second condition we may see that this f of x may not be continuous on this a to b. Okay, so on that basis this improper integral is divided into several categories. Okay, so you may write each category under a different type. Okay, for a better understanding. Okay, so first thing is that we will see what happens if in the proper integral this condition 1 fails. So condition 1 is that limits of integrations are finite, right? So I am taking the limits of integration infinite or minus infinite. Okay, so for example, suppose I will take the type 1 integral, okay, in which I am defining the integral. Suppose it is from a to infinite f of x dx. Okay, so see, in definite integral it was from a to b, but in improper integral this upper limit is infinite here. Okay, so how to solve such type of problems? Now here, whichever term is that infinite part, we will take this as limit b tends to infinite, and at place of infinite we will write b, and the low limit will be same, it would be a, and write the function. Okay, so in this way you have to solve this one. For example, suppose I'll write a question. Suppose I want to evaluate the limit 1 to infinite ln x by x square dx. See, here it is a kind of definite integral, right? There are limits, but the limits are not finite. Okay, so for this reason it comes under the improper integral section. So now what will we do? Now see, here there is the infinite value, we will take this as limit b tends to infinite b. Okay, so what I will write now to solve this one, I will write this as limit b tends to infinite, and in place of infinite I will write b, and in place of 1 simply 1. So it is ln x by x square dx. So now to evaluate such type of integral, we will first find this definite integral, then lastly we will apply this limit section. So how to solve this integral? Okay, see, this integral there are two functions. One function is the ln x function, another one is the 1 by x square function. Okay, so the 1 by x square function, I can write this as it is x square. I can take this to the numerator part, then it would be x to the power minus 2, right? Because we know the formula, whenever the x is in denominator part, then if it goes to the numerator part, then it will be the negative sign. Okay, so like this is the formula. Okay, so now see, here there are two functions. One is the ln x function, another is the x to the power minus 2 function. So if there are two functions, then we will have to use the integration by parts. Okay, so how to find this by parts integration? Let's see. So this is limit b tends to infinite, and this is 1 to b. Now I am writing this thing as x minus 2 into dx. Okay, now what is integration by parts rule? It is the eyelet rule. Okay, so in this we have to first define which function is the first function. As there are two functions, we have to first see which will be the first function. Okay, so what is this I here? I stands for the inverse functions. Okay, then L stands for the logarithmic functions, then A stands for the algebraic function. Algebraic means suppose x cube, x to the power minus 2. Okay, so like that. So see, already here it x to the power minus 2 is an algebraic function, so it will be the first function, and the ln x would be the second function. Okay, so see here the first function is the logarithmic function. Okay, in this order you have to find this one. Okay, so first should be the inverse function, so there are no inverse function. Next there should be the logarithmic function. So see, here there is a log function, so it is the first function now, and now this is the second function. So what is this eyelet rule integration then? Now it states that first I am writing this formula here. Okay, then I will solve this one. It is integration 1 to 2 dx. I am skipping the limits as we can do this after finding this integration. Okay, so this value will be first into integration of second minus derivative of first into integration of second and the whole integration. Okay, so this one is the integration for eyelet. If you want a separate video on how to use integration by parts, then please comment on this video. Now let's apply this formula. Okay, so we know the first function and the second function. We will use the bracket here. Okay, so now see what is the first part. It is 1 into integration of second. So first function is ln x into integration of second one is x to the power minus 2. So what will be the integration? It would be x to the power minus 2 plus 1 by minus 2 plus 1. Now the limit should be applied here. Okay, 1 to b minus, again there is an integration, so it would be 1 to b. Now derivative of first with respect to x. So what is the first function? It is ln x. So derivative of ln x would be 1 by x into integration of second. So integration of second function is x to the power minus 2. So the integration is, I'm writing it directly, it would be x to the power minus 2 plus 1 by minus 2 plus 1, again dx. Okay, because there is another dx here. Okay, then let's see this thing, and I'm taking this one whole bracket as this limit section we will apply later. Now let's solve little bit. What is this value? This is ln x into this value is x to the power minus 1 and this value is minus 1. Limits are from 1 to b. Then here it is minus 1 to b, again 1 by x. It is x to the power minus 1 by minus 1 dx. Okay, so in next step, let's take this minus sign to the outside. Okay, here this minus sign, here this minus sign, it will go outside. Here also it will go to outside. Then we will apply the limit. Okay, so it would be limit b tends to infinite bracket minus 1. Now this is ln x into x inverse. So x inverse would be 1 by x, and now the limits are from 1 to b minus, here there was a minus and this minus sign came towards outside, so it would be minus minus plus. So now this is 1 to b and this one is 1 by x into again 1 by x dx. Okay, so now let's solve furthermore. Now see, this value is limit b tends to infinite, this one is minus 1. Now I have to put the values here, so where I will put, now at place of x once use the upper limit, then minus once use the lower limit. Okay, so first it would be ln b. Okay, at place of x the upper limit into, again there is one x, so here it is b minus again the lower limit. So lower limit is 1, so it would be ln x, that is ln 1 into 1 by 1, then plus this value is 1 by x square dx, and the limit is again from 1 to b. Okay, so now solve. This one is limit b tends to infinite, this value is minus 1. Now this one is ln b by b minus this value is ln 1, so ln 1 is 0, so it is 0 into 1, then plus this one is 1 by x square integration. So if you remember this one, then it would be minus 1 by x, or else you can do this in this way, that it is 1 by x square, so it would be x to the power minus 2, then the integration would be x to the power minus 2 plus 1 by minus 2 plus 1. Okay, or else you can see the reference also. Here we have solved this part while finding integration of second. We have already found this one. Okay, from here also you can use this thing. Okay, so I'm writing directly, it is 1 by x square. Okay, so this one is minus 1 by x and the limits are from 1 to b. Now this minus sign I can take to the outside. Okay, I can multiply here, so this one will be limit b tends to infinite. Now it is minus 1 into ln b by b, then here this sign is a minus sign, and now here it is 1 by x, limit is from 1 to b. So now this value is limit b tends to infinite minus ln b by b minus this value. Here I have to use the limit of integration. So first I will use the upper limit, then I will use the lower limit. While applying upper limit, it would be minus 1 by b minus the lower limit, this one. Okay, this is the whole bracket. Now this value is limit b tends to infinite minus ln b by b. Now this is minus 1 by b, then minus minus plus 1. Now we will split this limiting value. Okay, so let's apply this one. So it is limit b tends to infinite minus ln b by b. And how to do this one? This one just simply use the linearity principle. Okay, and like this. Okay, so next one would be limit b tends to infinite 1 by b, then plus limit b tends to infinite 1. Now see what are these values. Here this minus sign, it is also constant, so constant can go out of the limit. Now this one is limit b tends to infinite, it is ln b by b. Now see what is this value, limit b tends to infinite 1 by b. So what is this value? This value would be 0. Okay, so just remember this one, this value is 0. Now see here it is limit b tends to infinite and the function is constant. Okay, so there are no b terms here, so I will not substitute b plus by infinite. Okay, so on constant limit will have no impact, so it would be just simply 1. Okay, so now let's solve this one. It is limit b tends to infinite ln b by b. So how to use this thing? Just at place of b I will take infinite. Okay, so in this place if I am putting b equal to infinite, so this value would be ln infinite by infinite. Okay, so ln infinite is infinite and this is infinite. So while finding limit, if there is a condition called infinite by infinite or 0 by 0, then we will have to use the L'Hospital's rule. Okay, so what is this L'Hospital rule? It will be only applicable while finding the limit values. Okay, if I am writing limit b tends to infinite and whatever the function is there, it comes to be in the form of infinite by infinite or 0 by 0, then we will use the L'Hospital rule. So what does this L'Hospital rule tell? It tells that just find derivative of both numerator and denominator function separately. Denominator function, okay, and you have to do it separately. Okay, so how to do that separately? Let's see. So we will find the derivative, right? First thing is confirm that we have to find derivative of this numerator and this denominator, and separately means they will stay in their position and we have to find the derivative. Okay, and now how to find the derivative with respect to which constant? If suppose I will ask that if it is to find derivative of ln b with respect to x or y or any other variable. So the answer is, what is the variable here? Here the variable is b. That means I have to derivative this ln b with respect to b only. Okay, so what will be the derivative of ln b with respect to b? Okay, so it would be 1 by b, right? Then it is derivative of p with respect to b, that is 1, and here this value is only plus 1. Okay, now see what is this value. This is limit b tends to infinite and now this value is 1 by b plus 1. And now see again this value, we know limit b tends to infinite 1 by b, this one is 0, and see what is this value, it is 1. So now we got the value. Okay, so another thing is that when we will see this improper integral is convergent or divergent. Okay, so this thing, just note down that improper integral is convergent if the integration value is finite. Okay, otherwise it will be divergent. Okay, so see, what is the integration value here? Here this value is 1. Okay, so for this reason we will tell that this integral is convergent. Okay, instead of 1, if suppose at some question I will find that the integration value is, suppose that integration value is infinite or suppose minus infinite, then I will tell that this integration is divergent. Okay, so actually in exams the question comes directly like, check whether this integral is convergent or divergent. So simply you have to find the integration value, and accordingly the integration value, if it is finite or infinite, then it will be divergent, otherwise it will be convergent type. Okay, so now we will see the next type of integration, which is the type 2. So there is not exactly this type 1 type 2 terms, but we're just categorizing it to understand better. Okay, so the next category is if the lower limit is minus infinite. Okay, so how to find this thing? So again, see here the lower limit is minus infinite, so we have to substitute this thing to new variable. Okay, so the new variable, it may be a, okay, or t or c or b, whatever you decide. Okay, suppose I want to take this as t, then it would be t tends to minus infinite, and here I have to write t. Okay, if you think that if you want to substitute this t to a, then here also you have to substitute it as a. Okay, so this constant is always on your own. Okay, a or b or c, whatever you want. B you cannot take because b is already in the upper limit. So to distinguish, let's do like this. Okay, so the formula just changed here. Okay, but the format remains the same. Okay, for example, we will solve this question. Suppose it is minus infinite to 2 dx by 1 plus x squared dx. So see here, this is the improper integral as the lower limit is minus infinite. So here, accordingly to the steps, we will first write at place of minus infinite. Suppose I will write limit a tends to minus infinite, and at this minus infinite place I will write a. Okay, simply I am replacing this minus infinite as a, and I will write limit a tends to minus infinite. It is this meaning. Then this is dx by 1 plus x square dx. Okay, so now see what is this value, dx by 1 plus x square. The integration would be, if you remember, it is the integration of tan inverse. Okay, so this value is tan inverse x, and the limits are from a to 2. So now I will use the limits. Okay, the integral limits. So at first we will use the upper limit, then we will use the lower limit. So it would be tan inverse 2 minus tan inverse a. Okay, so now I have to apply this limit part. Okay, so how to use the linearity principles. Okay, this limit will go to here and here, and the sign will remain same. Okay, so this value would be limit a tends to minus infinite tan inverse 2 minus limit a tends to minus infinite tan inverse a. Okay, so now see, again see here the variable, see there are no variable, it is tan function, it is a constant, so there are no a terms here. Okay, so the limit value would not be applied here, and this value is simply tan inverse 2. Now here in this section we will substitute a tends to minus infinite in place of a. So what will be this value? It is tan inverse minus infinite. Okay, and now if you remember, this tan inverse minus infinite would be minus pi by 2. Okay, or else in exam hall you will have the scientific calculator and there you can find this thing. Okay, so now what is this value? This is tan inverse 2 and minus minus plus pi by 2. Okay, so now see, this is a definite value. Okay, so definite value means there is no infinite terms here. Okay, for this reason this integral is convergent. Okay, so here in this type of integration, the integration is in the form minus infinite to infinite f of x dx, where f of x is continuous throughout the domain. Okay, so what does this means? So what is the domain here? Here the domain is minus infinite to infinite. So whatever may be the function, it is always continuous in this domain. So whatever functions are there, now let's say suppose all constant functions x, then e to the power x, such functions are continuous throughout the domain. Okay, so for such functions we can find this type of integration. Okay, for example, let's take, so for example, if I am taking minus infinite to infinite e to the power minus x dx, so you can check that this function is continuous function. So which function? This e to the power minus x. As you can see the graph, this is a continuous function. And how to check this one? You can use the Desmos calculator. Okay, there you can see that this function is continuous throughout the domain minus infinite to infinite. Okay, so now how to find out this one? So see, it is minus infinite to infinite. So in such cases where the f of x is continuous throughout the domain, here you can take a point break like 0. Okay, so in such cases just take a break point as 0. Okay, and split this integration limits from minus infinite to 0 and 0 to infinite. So what is the integration then? So see, here this type of integration, it is the type 2 integration, and this one was the type 1 integration. So use that format to find. So let's quickly solve. So here for minus infinite I will take suppose limit a tends to minus infinite. Okay, so previously we have taken b here. Okay, so a b whatever it may be the constant value, no need to worry. Okay, you may take on your own. Okay, so this one would be a to 0 e to the power minus x dx, and now this part would be limit b tends to infinite and 0 to b e to the power minus x dx. Okay, so for this infinite I am using b, and here for minus infinite I am using a. Okay, so now what is this value? This one is a tends to minus infinite, and this one is integration of e to the power minus x. So what is the formula? E to the power ax integration would be e to the power ax by a. So on that basis, what is a here? If you compare, it is the ax position, right? So at a place it is minus, so minus means it is minus 1. Okay, so a value is minus 1, so just substitute here. It would be e to the power minus 1x by minus 1, and the limits are from a to 0. Then here it is limit b tends to infinite, again also here same formula. Okay, minus 1, and limits are from 0 to b. So now this is limit a tends to minus infinite, and see this minus 1 is a constant, here this minus 1 is a constant, both will go out of the limit. Okay, then here I will take this minus sign. Now this one is minus x, limits are from a to 0. Now this one is limit, sorry, here this sign already changed, right? Due to this minus 1, this sign changed to minus 1, that is it is minus, so this value is minus x and it is from 0 to b. So now this one is minus limit a tends to minus infinite. This one is how to put this right hand limit, so x upper limit here minus 1 times the lower limit, so it is e to the power minus a, and minus limit b tend to infinite, again here the upper limit once minus lower limit once, so it would be e to the power minus b minus e to the power 0. Okay, so now let's see these values. This is limit a tends to minus infinite, this one is e to the power minus 0. Okay, so simply it is e to the power 0, that means this value is 1. Okay, but I will write here for your information. Now this one is limit b tends to infinite, it is e to the power minus b minus e to the power 0. So I will write these values at the end so that you will get a clear picture about how this e values works. Okay, so now we will apply the limits part. Okay, so this limit will go once here, then again minus here, as using the limit linearity principle, here also like this, and this limit will go here once again. So this value is limit a tends to minus infinite e to the power 0 minus limit a tends to minus infinite e to the power minus a, and the bracket closed because minus sign is outside. Okay, then minus this part is limit, also I am also taking bracket here, it is e to the power minus b minus limit b tends to infinite e to the power 0. Okay, now see here this e to the power 0, there is no a terms here. Okay, so limit a tends to minus infinite won't work, so this value is simply e to the power 0, then minus here limit a tends to minus infinite e to the power minus a, so at place of a we have to use a equal to minus infinite. So what will be this value? It is minus a is minus infinite, right? Then minus, next again see here this value is limit b tends to infinite e to the power minus p, so at place of p I have to take infinite, so this value is e to the power minus infinite. Then here see this is limit b tends to infinite e to the power 0, so there are no b terms here, so I can simply write this term as e to the power 0. Now to solve these things, see what is this value, e to the power 0, here we will use the general formats. Okay, before that I'm just simply rewriting this thing, just minus minus plus. Okay, then this one is minus infinite, then we will use the formulas. So as we know, e to the power 0 would be 1, and e to the power minus infinite is 0, and e to the power infinite would be infinite, so we will use these three values. Okay, so after using we will see this value is 1 minus e to the power infinite is infinite, minus e to the power minus infinite, this one is 0 minus 1. Okay, so whatever may be this value, see this is 1 minus infinite, multiply sign. Okay, it is minus 1 plus infinite minus 0 plus 1, so minus 1 plus 1 cancel, this is 0 and this one is infinite, so infinite minus 0, this one is infinite. Okay, so now see this integration value, this function my e to the power minus x dx integration minus infinite to infinite, this one became infinite. Okay, so here the integral is divergent. Okay, if the integration value is infinite or minus infinite, then it will be divergent one. Okay, So these three types will be discussed in the next part of this video. Hope you enjoyed. Thanks for watching, and don't forget to like, share and subscribe.